Um, hey everyone, welcome to Fiveable's AP Precalculus Preview Night 2. So this is just a preview night of what our cram sessions will look like. So it's kind of just a sneak peek, and I'll kind of recap what happened on Tuesday, and we'll talk a little bit about cram mode, and we'll jump right into the lessons. So cram mode includes 24/7 access to over 200,000 unique practice questions. We have tickets to all cram events and finales. So this includes every single AP class and all 40 prep books on one searchable platform for not just AP, but SAT and ACT needs. So how do you get to these cram finales? So you can get cram mode, which is either $10 a month or $40 for the full year, and you'll have access to every AP subject. So this is kind of how to make the most of your cram sessions. So they will be just like this preview night, but they'll be much longer, so 3 hours. We will kind of be a little bit going at a slower pace, and we'll cover the entire AP Precalculus course in depth, and this will be over the course of 5 days. We'll give study tips, we'll go over actual practice problems with answered and explanations, and we have replay available, so if you want to rewatch the event, if you didn't understand something, then you can totally do so. And if you take advantage of this opportunity and everything we're offering in these cram review sessions, then this will hugely help to increase your AP exam score. So the cram schedule for our AP review sessions, we're covering all 3 units that will be tested on the AP Precalculus exam. So this will be from May 8th to May 12th, and I just kind of want to introduce everyone. So I'm Shajita, and I'll be your main host for today. We also have Dina.
Hi.
We have Anna.
Hello.
We have Molly.
Hey.
And we have Andrew, who should be joining us shortly, and we also have teacher host.
Hi, everybody. Thanks for joining us.
And I would like to give a huge virtual round of applause to our amazing designers, Mariah and Ayman, who had actually prepared all of these slides and all of the future cram slides for us. So what are we going to be covering today? So we'll be previewing nights 3 and nights 4 of the actual cram sessions. So we have both of those nights split up, and we're covering an overview of each topic. So each night we're doing a unit. Nights 3 and 4, we're going to be splitting up unit 3. So we have a couple of sample questions, and we're just kind of going to be going over what the topic entails. So if you have any questions, please feel free to put them in the chat, and our team will get to them. We'll either show them on the screen and a host will answer them, or we'll talk about them at the end when we do a final Q&A. If you want something to be answered faster, then make sure to upvote it in the Q&A section so that we can get to it sooner. Another thing to note is please be appropriate at all times. Of course, this is still like a learning platform, so people are here to ace their exams, and please don't be rude or get in the way of their learning, and we will have to kick you if necessary. So an overview of the AP Precalculus exam in case you aren't familiar with it. This might be your first AP exam for some of you, so don't be stressed. It is a lot easier than it looks. I know it looks very overwhelming right now, but the exam is split up into 2 sections. So the first section will be most of your score. It's 40 questions. And the second section is an hour, and it's 4 questions, and it is 37.5% of your score. So these are all the units that AP Precalculus covers, but Unit 4 is actually not tested on the exam, so we will only be covering Units 1 through 3, as that's our focus here is to help you prepare for the exam. So what to bring to the exam? Of course, bring calculator, pencil, pen, and your ID. So the exam is weighted out of 64 points, and on the multiple choice, you can get up to 40 points. On the free response, you can get 24 points. So of course, the multiple choice is worth more. That's just something to note. The exam is also divided into 4 sections. The multiple choice is divided into 2 parts, one without a calculator and one with a calculator. And the free response section is also divided into 2 parts, one with a calculator and one without a calculator. Okay, so now we're going to welcome our awesome host, Dina, who will be going over trig functions.
All right, guys, hope you guys have been doing well since our last preview. So on the next slide, we can see that we're covering the big 3 trig ratios, sine, cosine, and tangent. And basically, the big idea for this section is determining the sine, cosine, and tangent of an angle using the unit circle, as many of you guys have heard. So let's get into it. On the next slide, you can see that we're covering first some ratios. So basically, we see that the 3 big trig ratios here, sine, cosine, and tangent, all have a definition. So sine is the ratio of the opposite side over the hypotenuse. So if you look at the diagram to the right, you can see that sine is y over r. And cosine, on the other hand, is the ratio between the adjacent side over the hypotenuse. So in this case, if we look at angle theta, the adjacent side, or the side right next to the angle, is x over r. And tangent is the side that is opposite of the angle and the adjacent side, so it's y over x. And as many of you guys have heard, this has the ratio of SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that might help you a little bit on your AP exam if you're struggling remembering these ratios. So on the next slide, we can see a little bit more about tangent. So basically the tangent of an angle in a right triangle, forgot to mention that in the last slide. These are very specifically for right triangles. And for this right triangle, it can be expressed in terms of sine and cosine as well. So the basically what is being said here is like it's like a proof. So because you know that tangent is equal to like y over x, you know that you can rewrite that y over x is y over r over x over r, because like the r's end up getting crossed out. And basically that's sine over cosine. That's just a proof in case you're wondering how those ratios work out at the end. And so from that proof, we get that tangent is equal to sine over cosine, and that's what we have there. And on the next slide, we can see a specific thing for the ratios of the angles. So we've probably covered 30, 60, 90, and 45, 45, 90 triangles before. But basically, the ratios of sine, cosine, and tangent here for specific angles are built off of those specific triangle cases. So these are just some values that you should have memorized for your AP test. It's just sine of 30 is equal to 1/2, cosine of 30 is equal to √3 over 2, and tangent of 30 is equal to 1 over √3. So some trick that we like use to remember this is that because 30 degrees basically has like 1, 3, you know, you have to put like the 3 in the denominator. And on the other hand, for tangent, if it's like 60 degrees, you're going to put the 3 in the numerator. And obviously they have a radical. But it's just good to have like some device where you can memorize those values. And we also know that sine of 60 is √3 over 2 and cosine of 60 is 1/2. And you can see that like the sine of 30 and the cosine of 60 are basically the same thing. So if you also want to use that method to memorize those as well, that also works great. And you also can see on the next slide, 45, 45, 90 triangles. This is a specific case that you have probably covered before, but we know that across the sides for the ratios of like the angles that are 45 degrees, you have 1 and 1 on the 2 legs of that triangle. And you know that the hypotenuse is √2. You can basically prove this by Pythagorean theorem, but what's important to know here is that the sine of 45 degrees is 1 over √2, which if you rationalize the denominator, it becomes √2 over 2 for sine and √2 over 2 for cosine. And tangent just becomes like if you divide those two together. So if you divide sine over cosine, or if you just memorize that, it's just 1. So all these are also very important to have memorized for your exam. On the next slide, we can see what a radian is. So a radian is basically the measurement of angles based on the length of an arc that is produced around the circumference of a unit circle. Radians are really important to know for your AP exam. And it's also really important to know that like basically the central angle on that arc is basically the length that the central angle covers on the arc is basically equal to the radian of the circle. And because this value of radian does relate to circumference, and because we know that circumference is 2 pi r, we know that that whole unit circle, which does have a radius of 1, basically covers the radians of 2 pi. And you can see that on the diagram to the right as well. On the next slide, we also have more information on circumference to radian conversions. So basically, as I've already stated before, because circumference is the measurement of 2 pi r, and because we're basically saying that, okay, so in their hypothetical scenario, the radius equals 1, and like it's going through the whole circle, we know that the whole circle is a radian of 2 pi. And there is a conversion factor. If you are into chem and conversion factors a little bit, we know that 2 pi radians is actually 360 degrees around the circle. So if you don't want to like mentally think about how to convert those two, you can just use that conversion factor to get from angles to radians or to get from radians to angles. On the next slide, we actually see this big thing is the unit circle. So the unit circle is actually really important to know for your AP exam. Basically, it's just what every single like trig problem is made from. And a unit circle, basically, as I've already said, has a radius of 1. And this basically gives you a way to go from like angles or radians to like points on a unit circle. So on this unit circle, we can see like an x and a y coordinate. And basically, those two relate to sine and cosine values, right? So you know that like the x coordinate basically on the unit circle is like the cosine of that angle, and the y coordinate on that point in the unit circle is the sine coordinate of that angle. So let's take pi over 6 as an example. We know that if we convert pi over 6 from radians to degrees, we know that that's 30 degrees. And from previous slides, we know that, okay, the sine of 30 degrees is 1/2. And you can see that the y coordinate on that unit circle is also 1/2. So the sine and the y coordinate are coordinating there, and that also works for the x coordinate. It's just really important to understand this unit circle. I can't stress that enough. And 4 really important points on this circle are also at the axes. So we can see that the rightmost point on that circle is 1, 0. And then on the y-axis, the highest point is 0, 1. So it's just worth memorizing those and like being able to basically visualize this unit circle on the test. And basically on the next slide, we can also see some trig ratios for very special angles that you should also have memorized for your test. So if we just think of these, right, sine of 0 degrees, we know that sine is y over r basically. And since we know that r is 1, but we know that at that x-axis on the right, the sine value equals 0 because the y coordinate of that point equals 0. So if you're taking this, basically the sine measurement, it's just 0. Cosine, on the other hand, on that x-axis, is you know that the x coordinate is 1, so you're going to do 1 over the radius of 1, and that's equal to 1. And you can work out something similar for 90 degrees where like this, because the y value is 1 and the radius is 1, it's 1, and the cosine of 90 degrees is 0. That's just another way to like think about those values if you're just looking for different methods to memorize them. But tangent of those two angles is actually really important. So we know that tangent is y over x. So we know that at 0 degrees, the y coordinate is 0, but then the x coordinate is 1. And any number, like if 0 is in the numerator and you're dividing by some number, that number is always 0. On the other hand, tangent at 90 degrees is actually 1 over 0 because that is the y value of 1, as you can see on the unit circle, over the x value of 0. And any number divided by 0 is actually undefined. So if you're asked for the tangent of that angle, it's always important to remember that that's undefined. And some way you can memorize this is that tangents on the unit circle, especially in the first quadrant, are increasing from 0 to 90 degrees. So the highest value is 90 degrees, and that's undefined. And then the lowest value at that point is 0, and that's for the first quadrant. More information on the unit circle on the next slide. As I've already said, you can see that the points here they correspond to the angle on the sine and cosine values. And so as I've said, I can't stress this enough, the x coordinate is the cosine of the angle and the y coordinate is the sine of that angle. It's just, if you want to remember that, it's just worth, like when you get your test and when you get like a trig question, it's just worth writing that down so you don't forget that. And we also know that the distance from the origin to any point on the unit circle is 1 because that's just the radius of the circle. So that distance is always 1. So on the next slide, we can see that the angles on the unit circle are typically measured with radians, and they are included on that positive x-axis. Now, some key angles to remember are 0, pi over 6. Pi over 6 is 30 degrees. Pi over 4, which is 45 degrees. pi over 3, which is 60 degrees, and pi over 2, which is 90 degrees. So I think it's important to like familiarize yourself with the coordination of like that radian and that angle measurement in degrees if you are used to it in degrees, but for your AP test, it's important to know it in radians. And the patterns are basically repeated across every quarter. So if you look on like the second quadrant, right, the one on the left side towards the top, so where the y is positive but the x is negative, you have a negative x value, but you still have a positive y value. So it's important to be able to make those distinctions between positive and negative values. And we also have symmetry on that unit circle. So on the next slide, you can see a practice problem. Now, this practice problem is in no calculator, so you should be able to tell these trig values, memorize, or like be able to think about them. So we have following ratios on the right. And we're just going to give you like a couple minutes, like maybe 2 minutes to just figure out all these values, but you should be able to figure out these values very quickly. So how about you try the values on the right for a couple minutes and we can see what you get for those. Okay, so hopefully you were able to solve those out. We're so sorry for the silence. It's not supposed to be like that, but yeah. So basically you're supposed to be able to think of these ratio values quite quickly on your test, so it is worth memorizing, but hopefully you got these right. And so the sine of pi over 6, as we've said, pi over 6 is 30 degrees, so the sine of that is 1/2. Cosine value of 3 pi over 4 is root 2 over 2, and I believe that's supposed to be a negative value. On the other hand, the sine of 4 pi over 3 is negative root 3 over 2. The cosine of 3 pi over 2, which if you look at it on the unit circle, that's actually 270 degrees. So it's like the opposite of that 90-degree angle, and that's 0. The sine of pi is also 0. That's the x-axis on the left. And the tangent of 5 pi over 3 is in fact negative root 3. So what you can memorize is that tangents with radians, specifically with angles and radians. So you know that there's 1 3 in the denominator, so your tangent value is going to be root 3. You obviously have to figure out the sign. But let's say the tangent was like 5 pi over 6, then you would have to do something like negative root 3 over 3, because like the 6 basically is like 2 3s. That's just another way you can memorize it, however works best for you. Just know that you have to have these values memorized by your test. And that's it.
All right, so we just kind of went over our trig functions, and you saw that they take in an angle as an input, and the output is going to be a ratio of side lengths. And so now talking about your inverse trig functions, those are going to take in a ratio of side lengths, and they're going to output the corresponding angle. So going on to talk about that a little bit more, the inverse of your sine function is going to be written as, you could see, sine to the -1 or more commonly arcsine, especially when you're just speaking. Cosine would be arccosine, and tangent would be arctangent. And you can think of these inverse trig functions as kind of undoing your trig functions. And so due to these like reversed inputs and outputs, if you look over to this table, you can see that the domains and ranges are actually also reversed. So for your trig functions, the domain, the all possible x values are going to be your angle measurements because that's your input. And then for your range, it's going to be all of the possible side ratios because that would be the output of your function. And then it's the opposite for your inverse trig, where your domain is going to be the ratio of sides and your range is going to be the angle measure. So speaking on right triangles a little bit, let's say that you're given this triangle here, where you are only really given the two side lengths. You have your 3 centimeter side length and your 4 centimeter side length. The input of your function is going to be a ratio of sides. It's going to be 3/4. And you could see, we were speaking earlier on SOHCAHTOA, tangent would be your opposite over hypotenuse of the angle that you're looking for. I mean opposite over adjacent. So the opposite angle side to x would be 3, the adjacent side would be 4, and so your input's going to be 3/4. But given that that's not an angle, you can't use your regular tangent function, so instead you're going to use the inverse. So taking inverse tangent of 3/4 is going to actually give you that angle that would have given you 3/4 if you plugged it into the original tangent function. So you'll see here that whenever you're solving equations that involve your trigonometric functions, a lot of times you'll come down to a point where you could see with sine of x equals 1/2, you're actually looking for the angle which will give you a certain side ratio. So in order to solve for x, you can't use your regular sine function. You're going to have to actually convert that to arcsine in order to find x. So it's just important to note that with a lot of different problem solving within trigonometric equations, you're going to have to use your inverses in order to actually solve for your variable. So we discussed how the inverse trig functions, they take in the ratio of sides and output angles. And we talked about how the range of values is therefore the set of all angles that the trig function could encompass. So, for example, you could see up here in our figure, for the function of cosine of x, the range would be from -1 to 1, because those are all of the possible ratios that the side lengths could take. However, for arccosine, the range is instead going to be what the domain was in the regular cosine function. So it's going to be all of the possible angles that it could take, so from 0 to pi. So we have a little practice problem for you here. So go ahead and try to solve these inverse trig functions without using your calculator. So just remember the different inputs and outputs that your inverse trig function will have. All right, guys. So it's really important to note when you're solving these problems that you're going to need to have your unit circle memorized in some sort of way. Because whenever you're looking at these problems, you know that the input is is the ratio of sides, and so you're looking for the angle. And so what you're really wanting to know is what angle could I put into the actual original function to get this ratio of sides. So take, for instance, b, where you've got arc sine of the square root of 2 over 2. So what you're going to be looking for is what angle you know will produce square root of 2 over 2 in the original sine function. And you probably know, if you have your right angles, not your right angles, your special right triangles, as well as maybe your unit circle memorized, that would be 45 degrees, which is pi over 4 in radians. So just analyzing the unit circle and trying to memorize that is really going to help you out with these problems. So we have one more practice problem for you in this section, and we're going to speak a little bit about period and amplitude here. So the figure here shows the sinusoidal function g, and you're trying to find the values for the period and amplitude of this function. So go ahead and try that out. No calculators. All right, so if you're looking at this graph here, you can see that this function, it's going to return to its original position when x is equal to 8. So you know that it completes one period in when x equals 8. So the period for this function is going to be 8. As for amplitude, amplitude is going to be the distance up from the x-axis, I mean. And so you can see that it goes up to y equals 3. And so your amplitude for this function is going to be 3. So the answer was B. Great job, guys. I am now going to hand this off since we've covered our inverse trig functions. And I believe that Tom is going to handle some of our important trig identities.
Hello, everyone. So trig identities are, it could be a little bit tricky. And for a lot of you in pre-calculus, this could be a little bit overwhelming. The good news is that this course doesn't require very many identities to be sort of at the tip of your fingers. So we're really just looking at two main groups of identities. First of all, the Pythagorean identities that we'll talk about first, and then it's just the sine and cosine sum identities. Those are the only ones you need to know, but they will not be given to you on the exam, so you're going to need to know these going in. So if you look on the left here, the most common version of the Pythagorean identity says that sine squared theta plus cosine squared theta equals 1. And the first time you saw that maybe in this course, that might have seemed a little bit overwhelming. But if you think about it in terms of what you know about geometry and right triangles, you can easily say that x squared plus y squared equals 1 squared. That literally is the Pythagorean theorem for a right triangle. And we just replace x with cosine and y with sine. So the sine squared plus cosine squared equals 1 is a fundamental identity that in many ways kind of comes naturally from geometry. Now, having said that, we can also generate two other versions of this simply by dividing each term in the original Pythagorean identity either by sine squared all the way across the board or by cosine squared all the way across the board. And I'm pretty sure at some point in your course you would have done that to derive these. So you don't really need to memorize all three of these. If you simply know the original one with sine and cosine, you'll be able to generate the other two on your own. Now, the other two big identities, or the other two types of identities you're going to need to know are the sum and difference identities. And I'm not going to get into all the details about this. These are just, again, basic identities that allow you to evaluate sines and cosines for angles that maybe don't show up on the unit circle, but that can be formed by adding or subtracting some of those more fundamental angles. One of the ways I remember this, if you look at the sine versions of these, you'll see it's always sine, cosine, cosine, sine. If you look at the cosine version, you'll see it's cosine, cosine, sine, sine. So that's a little bit you're going to want to remember as you go through this. What most students really struggle with is trying to recall the SIGN, that is the plus or the minus sign in these identities. And the very easy way that I've worked with my classes is this, and bear with me here. Sine stays the same. That means when you're working with the sine identity of either sum or difference, if it's a sum in the problem, it's a sum in the equivalent version. If it's a subtraction or a difference in the original problem, it's a difference or subtraction in the regular problem. So sine stays the same. The cosine one's a little bit weirder, but bear with me here. I say cosine changes, because the word change starts with the letter C, but it's pronounced differently, right? But cosine changes. So if you see cosine of A plus B, we actually put a minus into the identity. And if it's cosine A minus B, we put a plus in the identity. These are things that are worth memorizing for sure. Okay, go ahead and look at the next slide now. Now, the double angle identities, to a lot of students, feel like it's something brand new. But really, sine 2 theta is nothing more than sine of theta plus theta. So if you apply the sum identity for theta plus theta, it will automatically lead to this identity. And I will tell you that sine 2 theta identity is very, very common in the trigonometry world. With cosine 2 theta, you can apply the addition or the sum identity and get cosine of theta plus theta. But what's interesting about that is that we get this cosine squared theta minus sine squared theta first. But then when you remember back to the Pythagorean identities, you realize that you can replace cosine squared with an expression that involves sine squared, and you end up with the bottom version. You can also replace sine squared in the first one with an expression involving cosine squared, and you get the middle one. So all three of these versions are equivalent, and sometimes it's more useful to use one over the other, but they all come from the sum identities of cosine and sine. So at this point, we're going to start playing around with what it looks like to solve equations and expressions. And what's going to happen sometimes is you're going to be given a problem in a form that isn't immediately solvable, and you'll be able to use one or more of these identities to rewrite the problem in such a way that that you can't actually go through and solve it. This is going to be a topic for night 4. So this is just a preview of what you're going to see, but we're going to look at the process of solving trigonometric equations by rewriting trigonometric expressions by using identities. So we're going to give you a little practice problem here. There are actually 2 problems here. And you may have done a problem like this in your course. We've left the sum and difference identities available to you. Your task here is going to be, without using a calculator, to try and figure out 2 angles that either add or subtract to make 17 pi over 12 or 5 pi over 12. Because those are angles that don't show up on our unit circle like some of the other ones do. And then once you have decided how to add those 2 angles, you can then apply one of these, well, one of the 2 sines or one of the 2 cosines for each problem and come up with an answer in exact form. Notice that this is a non-calculator problem. So you should not be giving your answer in a decimal form. Your answer should have radicals in it. And we'll talk through this in just a minute, but you got 2 minutes to go have it this one. Okay, well, how did that feel? This page is a little bit lengthy. What I'm going to encourage you to do, instead of feeling like you have to write this all down, when I get to the other side, when we finish this all, I'm just going to pause for a couple of seconds. There you go. That's great. If you want to have this entire page, just take a picture of it. It could be really nice to refer back to later. But I want to highlight a couple of the highlights of this solution. For sine of 17 pi over 12, there are actually a number of combinations of angles that will make 17 pi over 12. This particular example uses 9 pi over 12 and 8 pi over 12. And those may not be familiar to you, but when you simplify them, you'll get 3 pi over 4 and 2 pi over 3. And those are unit circle angles, which means they should be manageable to simplify this expression without having to use a calculator. So we apply the sine addition or sine sum identity. We have a sine of 3 pi over 4 plus 2 pi over 3. And then all the rest of it is just simply going to be a process of evaluating each sub-expression and coming up with a final answer, which is minus square root 2 minus square root 6 all over 4. One thing to notice is that 17 pi over 12 is more than pi, which means this angle is down in the third quadrant, so sine will be negative there, and in fact, the answer comes out to be negative, and that's a confirmation of what we might have predicted. On the cosine side, you can see we chose two angles that subtract to make 5 pi over 12, 3 pi over 4 and pi over 3, actually 9 pi over 12 minus 4 pi over 12. And once again, we apply the subtraction or the difference identity for cosine. And again, you can see how the values, how it all leads to an answer that is positive, it turns out. Minus square root of 2 plus the square root of 6 is positive, all divided by 4. 5 pi over 12 is just shy of pi over 2. And so we're still in quadrant 1, and we would expect cosine to be positive there, and in fact it is. So if this is something that is not so familiar with you, there's a lot of practice problems you can find, maybe in your textbook or just even online, where you can practice this. Once you get good at this, I think you can get some confidence built up. So if you see one of these, probably you would see this in a multiple choice question. You could probably tackle it pretty well. Okay, with that, I'm going to welcome Anna to the stage.
Hey guys, so good to be back with you. We're gonna now cover some polar coordinates. So I want you to, actually we can go back, or it doesn't matter, but just when you're thinking of any polar coordinate, think of a dartboard. So you want to think of like this instead of in a graphical form, like on your calculator. We're actually thinking like in circular form. So it's kind of like a dartboard, and you can describe position on a grid of circles based on the distance and the angle. So the distance from the center of the point is the radius, and then the angle it makes with the reference line, which is usually the positive x-axis, is that angle theta that we'll learn how to solve. So let's then look at comparing to rectangular coordinates. So this is the one that we're like more familiar with, what we started learning. And that's our like rise over run. So we have like our run and our rise directions, which is our horizontal and vertical. So we use the points X and Y to plot. But polar is distance from the radius, distance from the center, which is the radius, and then the angle of the counterclockwise rotation, which is theta. And then you should know this, that counterclockwise is the direction that we move on the polar scale. So if you get a positive angle theta, that means you're going counterclockwise. But if it's negative, that means you're going the other direction. So just keep in mind, like 270 degrees positive would be the same as like negative 90 degrees, because they're in the same place, but you can get there by either direction. So yeah, just make sure you're paying attention to the signs there. But that's rectangular versus polar. As far as writing the coordinates, just make sure that if you see like X and Y, that you should think rectangular. And then as far as polar, just think R and theta. Those are just like your tools for plotting points on both of those coordinate planes. Okay, so now we're going to talk about some converting of the coordinates. So for that, we can convert rectangular coordinates to polar coordinates using trig. So these are some formulas you should also know. If you're jotting them down, you should jot these ones as well. So make sure that when you're so you're going rectangular to polar in this first one, when you're trying to find your R, because that's like technically your X just in polar form, that you have it in terms of rectangular, right? So you have an X and Y, and the way you're going to do that is plug that into this first formula here, and that calculates the length of the hypotenuse of a right triangle formed by those points X, Y, and the origin, and then that gets you R. So you can see kind of this like Pythagorean theorem going on for that to find that R. And then as far as the theta, that is just how you calculate the angle. And just whenever you think of calculating an angle, you need to use inverse trig. So that's why we use this inverse tan. And then that's a convenient way for you to plug in both the X and the Y coordinate to get the polar coordinate. So then that gets you the r and the theta. Okay, and then as far as converting polar to rectangular, you're given a polar coordinate in terms of r and theta, and you need to then come out with x and y. And so in that case, we're going to use more trig. So basically, as Dina mentioned earlier, we always want to think of cosine as like being a horizontal distance or like an x, and then sine should correlate to a vertical distance or a y. So as you can see in these formulas here, these are a great way to find your rectangular point. So yeah, I mean, based on that angle theta that forms the hypotenuse, you can solve for the horizontal and vertical distances from the origin, which are your rectangular distances. Okay, yeah, make sure you memorize those, take a picture or whatever, but yeah, we can move on. Cool. So we'll get some practice in. Hopefully you have those formulas at the ready. So this one we are converting, it looks like, from rectangular to polar. So we're given two xy coordinate and then try to make them into r and theta. Okay, hopefully that was enough time. There's your solution. And then just a quick reminder to everybody, it looks like this is kind of a new subject for some people. Don't worry, if you're there on cram nights, we're going to go way more into depth with this. So stick with it for today, and we'll see you on cram night, and we can really, really get into this. Okay, but for our solution here, we have, we were given it in rectangular form, and then we converted to our polar form using the hypotenuse and then that kind of like Pythagorean theorem that gives us the radius or the hypotenuse. And then to find the angle, we did that theta and then the inverse trig to get that. And notice that it's a negative angle, a negative theta angle there. So that negative 1.03 in radians is about negative 60 degrees. So if we go back a slide, you can actually kind of see right where that point is. Do you remember, like, so yeah, we have the point, wait, back. One more. Yes, yeah. Okay, so for this one, so just a reminder of the solution, we solved radius to be 5.83, and then we solved for the angle to be negative about 60 degrees, right? Because it was about -1 in radians. So you can see right about where that is on the origin. So it kind of on the plane. So that kind of makes sense, right? Just just converting, but it's the same exact point. Okay, now we can move on to our next practice question, which is converting opposite, polar to rectangular. So you get a calculator for this, and make sure you use your strategies with the trig to get those x and y values. Okay, go for it. Okay, here's our solution. Hopefully that all went well. So yeah, just so you know, you have your points that you found with the trig, and those should be your x and y. So we have like a negative x value and a positive y value. So let's go back one slide just to check that point. And that makes total sense, right? We have about negative 3.7 in the x and then about positive 1.53 for the y. So yeah, that's a good, if you're ever given like an actual picture of it, it's a great way to check your work. Okay, let's move on to complex numbers real quick. We'll just touch on this again. We're going to go way deeper into this on our actual cram nights. But just know that we're going, the way that we kind of use these is by extending like our real number system to include solutions to equations like x squared plus 1 equals 0, which has no real solutions, right? So we use this to solve stuff like square roots of negative numbers. So the formulas for these are the rectangular, which are the a plus b, and then you multiply that by an imaginary number, that's I, and then polar, which is r times cosine theta plus I sine theta, and that I is an imaginary number. So the thing is with those is you still should just remember that polar is the r, which is the distance from the origin, and theta, the angle, and that rectangular is still in the x and y form. So as you can see kind of in that bottom there, where we have like this written out a little longer, you can think of the like a part as being this like x, as being like the x axis for your rectangular. And then you can think of the b as your y, and then that is what is multiplied by the I. And then same deal with polar. You can see that as well. So we'll get plenty of practice with this. Let's do an example so you can see that. So we'll do our practice slide next. And then these should, okay, so they'll have the answers revealed soon. But yeah, remember those formulas. And what's going to happen is you're going to do the same conversions you were doing before. So you're still going to like convert from rectangular to polar and polar to rectangular, but just make sure it's in that form we were talking about before, that like a plus bi, or that the cosine r cosine theta plus I sine theta. So yeah, just have a go at it, and then we'll talk about the answers. Okay, we're actually going to end a little early here. Sorry to cut the time. We just want to make sure we end on time. So yeah, those are your answers. Just make sure you can check whatever. We can move on. We're going to do a quick MCQ practice because this is like practice for the actual, we can go on to the next slide. This is practice for the actual AP exam. You'll see it soon. There we go. Okay, there she is. So, yeah, this is a calculator question, and go for it. We'll talk about it. Okay, cool. Hopefully that was enough time. We are going to cut it a little shorter. But then for this explanation, just know that I'm going to kind of like run through this quickly, but the normal sine function starts at 0 and oscillates between -1 and 1, right? That normal sine function that you know. And then this one, we are told that it starts at -1. Right? So that shifts it down. And so now the sine function oscillates between -2 and 0. So that keeps all points below the x-axis. Now, plug in the possible points between 0 and pi/2 to see the shape they're moving in. And that's the range we're given, right? 0 to pi/2. And as you can see, it's kind of like graphed in Desmos here. You can imagine this like shifted sine graph that is going upward, and it's actually like going toward the x-axis. So it looks like that picture there. Cool. That's all from me, guys. Thank you so much, and see you on cram night.
Okay, we're going to wrap up with one more practice problem. I know we're right at the top of the hour. We want to be respectful of your time, but I do want you to see what a sample free response question might look like. So I want to point out here that this question is actually lengthy. Each question is going to take about 15 minutes on average for the free response. They're going to typically have 6 parts. This one has 6 parts to it, each part worth 1 point. All I want you to look at tonight are the 3 highlighted parts. That is A2, B1, and C. We're going to put the timer, it's going to say 5 minutes. We're just going to run it for 2 minutes, though. We're going to stop the timer when it gets down to 3, and we'll talk through each one of these. The first one, we're rewriting an expression with only cosine. The second one, we're solving an equation. And the third one is essentially solving an equation, again, with a slightly different set of values. So we'll start the timer. We'll take 2 minutes on this, and then I'll take you through these solutions. Okay, this is a 10-second warning. Okay, great. So I want to remind everybody, you're going to have a lot more time than we gave you tonight to do this problem. This would have been about 7.5 minutes you had been given. We just did it in 2 minutes so we can just do a quick look at it. If you'd like to review this problem, go ahead and take a screenshot or take a picture of this with your camera. We'll leave it up for another few seconds so you can capture this problem. And then when we're ready, we'll move on and look at the next slide, and we'll walk you through the solutions. Again, this is just a brief overview tonight. We're going to go into a lot more detail. We'll be able to walk through this a little more slowly and give you some confidence to tackle these problems. Okay, let's go ahead and take a look at the solution we're at right now. Part A asks us to rewrite h of x with only cosine in it. And what you notice is that the first expression on top is one of those Pythagorean identities. So you didn't have to specifically memorize the identity, but you do have to recognize that that's one of them. And then we replace it with negative cosine squared. One of the cosines cancels, and our final answer is minus cosine x. On this particular one, 1 point was given just for the answer. Nothing about domains or any restrictions. For part B, we were given an equation, and we're asked to solve only for values in the interval 0 to pi over 2. Some of you have seen problems where you had to come up with 2 answers, or sometimes even multiple answers with periods. In this case, you can see in the upper right now, we can factor out a cosine. And now we have 2 factors. We use the zero product property, one of those algebra 1 topics. We get 2 values for 2 equations, one for cosine, one for sine. And that leads to 2 answers. And you had to get both answers correct. Again, just between 0 and 2 pi. Notice the bracket on the problem, which means pi over 2 is included in the possible solutions. And you had to get both of them right to get the 1 point. Now for part C, we're given a y value, essentially. It's m of x. And we have to solve for x. And you'll notice that if you subtract 4, we're back to a cosine equaling a half. And at this point, we have to use some of those periods again. And this is where you're starting to see some of the things you saw in class, where we give an answer on the unit circle, and then we add 2 pi and multiples of 2 pi because of the periodic nature of cosine. And then when we divide everything by 2, the pi over 3 and 5 pi over 3 become pi over 6 and 5 pi over 6. And the period now drops from 2 pi to pi. So that's a lot. And there's a lot more in that question. But for the sake of what we're doing tonight, that was just a sense of what a trigonometry question might look like in a free response. Okay, with that, I'm going to hand it back to our host for tonight, Trijita, and she is going to take you home.
Okay, guys. So we're just kind of going to wrap up for tonight. If anyone has any questions, I know we're a little bit over time, but if you have any burning questions, then please put them in the chat, and we can go over them. But yeah, so just again, a reminder, if you liked what you heard today, then please check out our cram sessions. They will be starting on May 8th. Remember, you get 24/7 access to 200,000 questions, and this you're not paying for just this AP Precalc cram session, you're paying for all subjects. So if you're taking any other APs, this is just a great resource, and I highly recommend that you invest in this. Again, our cram schedule, so we'll start on May 8th, we'll do Unit 1, and we'll do Unit 2 on May 9th, and we'll split up Unit 3 between May 10th and May 11th, and May 12th, the day before the exam, we'll have our cram finale. So yeah, please make sure to follow us on at ThinkFiveable on Instagram, and yeah, that'll be it for tonight. So thank you guys.